Hello, good morning. Today in this video we are discussing about one more important topic from the special theory of relativity. Already we are under the special theory of relativity. Under the special theory of relativity we discussed so many things. The first we discussed about the Newtonian mechanics, Newtonian transformations, that is Galilean transformations. The Galilean transformations does not satisfy all the things, whatever the things, velocity is variant and change of the wave from one place to another place, electromagnetic waves shapes are changing from one frame to another frame. So these defects were overcome by using a low range transformations. Clear? So low range transformation, after low range transformation we discussed about the Einstein mass variance and the low range variances and low range invariance also we learn, and then we discussed about, today we have to discuss, that is very important, Einstein's mass energy equivalent equation, that is E is equal to mc square. It is a great discovery. Maybe every person using E is equal to mc square in our daily life. Suppose in daily we are cooking by using the flame of the gas. If gas content is more, mass of the gas is more, then you will get the more energy. So that is also E is equal to mc square. Mass is proportional to the energy, energy is proportional to the mass, vice versa. He discovered the new equation. That equation is a Einstein's mass energy equivalence equation. How he discovered today, how he derived, once you have to see the derivation of the E is equal to Einstein's mass energy equation. Einstein's which equation? Mass energy equation. Einstein's mass energy equation. Suppose if you have to take a body, so that body, suppose any body, it does not matter about the shape, the mass of the body is equal to m, the mass of the body is equal to m. You have applied the force on this body, F force you have to apply on this body. This body can displaced. So this body can displaced from here to here. So that displacement of, you have to take dx displacement is there. Maybe this body is moving from here to here. So once you have to apply the which one you have to apply? You have to apply the force on this body. Now this body also moving with velocity. How much velocity? This body is moving with velocity v. So therefore what we have to write, by using a Newton's second law. What is the Newton's second law? Once you have to see, according to the Newton's second law of motion, second law of motion, Newton's second law of motion. What is the second law of motion? Force is equal to the rate of change of momentum d by dt of momentum, the rate of change of momentum. But momentum p is equal to m into v. Momentum p is equal to m into v. So therefore f is equal to d by dt of m into v. What we have to write? D by dt of m into v are writing. Now once we have to see here, m is also variable. It is a relativistic case. Already in the yesterday we discussed mass is varying with velocity under the relativistic case. So that's why mass and velocity both are varying. You have to differentiate this implicitly. F is equal to d by dt of m into v. You have to differentiate both sides implicitly. Differentiate implicitly on both sides. What will happen once you have to see? Differentiate implicitly. You have to differentiate implicitly. You have to take on this side, you have to differentiate. D is equal to, so by UV method you have to differentiate, otherwise you have to take this one. UV method you have to apply. Maybe this is U and this is V. You have to take m into dv by dt, m into dv by dt plus v into dm by dt, v into dm by dt, which is equal to f is equal to. So now you have to take this expression and multiply both sides with dx, multiply, take this equation, multiply dx on both sides, multiply dx on both sides. What will happen? Once you have to see, f into dx is equal to, f into dx is equal to m into dv is divided by dt into dx plus v into dm by dt into dx you have to take. So therefore f into dx is equal to, this is the work done on the system, w is equal to f dot dl is equal to w, m into dv by dx. So dx by dt we have to take it as a v, m into v into dv, m into d into dv, so plus v into, so dx by dt is equal to one more v square into dm. So therefore what we have to write, w is equal to m into v into dv plus v square into dm plus v square into dm. So this one, this work done is nothing but, the work done can act as a change in the kinetic energy. W is W, it will become as a kinetic energy, right? This W is equivalent to the change in the kinetic energy. How we have to take? So the kinetic energy of the particle, this dW we have to write it as a dt is equal to mv dv plus v square into dm. This is the equation number 1. What is that? dt is equal to mv dv plus v square into dm. This is equation number 1. From this equation what we have to tell, the kinetic energy of the particle to be equal to, the kinetic energy of the particle to be equal to, this is the kinetic energy, the kinetic energy of the particle to be equal to the work done by external force increasing the speed of the particle from 0 to which value? V value. From 0 to V value how to write. But you know one thing, so according to the Einstein's mass invariance, according to the mass relativity, mass in relativity, according to the mass in relativity, Einstein's mass in relativity, m is equal to m naught is divided by square root of 1 minus v square by c square, correct? Now you have to cross multiply m into square root of 1 minus v square by c square is equal to m naught, is equal to m naught, square on both sides, m square into, so c square minus v square is divided by c square is equal to m naught square. Say m naught square you have to write here, right? Correct? So therefore you have to take this expression, so you have to take this expression, which expression it is? M square into c square minus v square is divided by c square is equal to m naught square c square is there. Take this expression and differentiate implicitly. Here you have to write differentiate implicitly. How we have to differentiate above the expression? Differentiate implicitly, differentiate implicitly, differentiate implicitly means how we have to differentiate here? Mass is variance, no? So that's why 2m into dm into c square by v minus v 1 by c square into 2v into dv minus 2v into dv, c square by c square, that is this equal to 1 it will come, right? Minus 1 by c square 2v into dv which is equal to m naught is the constant value, m naught square into m naught is the constant value, m naught square is equal to, you have to differentiate, you will get the 0, that constant value you have to differentiate, you are getting the 0. From this what we have to write here, once you have to see here, so 2m dm 1 by c square into 2m vm 1 by c square into plus one more thing is there, by UV method you have to differentiate, and again so you have to take m square into, you have to take m square into 2m dm, you have to take first you have to differentiate this one, which one you have to differentiate, 1 minus v square by c square you have to keep here, 1 minus v square by c square, 1 minus v square by c square plus m square into 1 minus 1 minus 2v 1 minus 2v dv is divided by c square is equal to 0, right. So I am differentiating, first you have to differentiate the first term, you will get the 2m dm, right, into again same thing you have to write 1 minus v square by c square you have to write, plus again you have to differentiate this one, so again you have to differentiate this one, m square into 1 minus 2v dv is divided by c square, which is equal to 0. From this what we have to write, so you have to simplify this expression. How you have to simplify, once you have to see, take this equation, you divided by 2m on both sides, you divided by 2m on both sides, so 2 ja get cancel, m here ja get cancel, so 2 1 ja you have to take here, so which one you have to see, this is the 0 it will come now, if you have to differentiate 1 that will going to become 0, so write 2 1 ja get cancel, m get cancel. So therefore the rest of the things you have to write dm into 1 minus v square by c square, 1 minus v square by c square plus m into which one we have to write, minus m v dv is divided by c square, which is equal to 0, minus m v dv is divided by c square is equal to 0. Now you have to rearrange this expression. How we have to rearrange this expression, once you have to see, dm into 1 minus v square by c square minus m into which one we have to write, m into v into dv, m into v into dv is divided by c square is equal to 0. So now you multiply these things, dm into c square minus v square into dm minus m into v into dv, which is equal to 0 into c square. So therefore what we have to write, dm into c square minus v square into dm minus m into v into dv is equal to 0. So therefore these expressions you have to bring into this side, dm into c square v square dm plus m into v into dv, m into d into dv. This is the equation number 2. So which one it is? Equation number 2. From equation number 1 and equation number 2 you have to observe. According to the equation number 1, m into dv plus v square into dm is equal to dt. What is the equation number 1? Equation number 1 is m into dv, m into v into dv, m into v into dv plus m into d into dv plus v square into dm is equal to dt. This is the equation number 1. What is our equation number 2? Equation number 2 is m into v into dv plus v square into dm is equal to v square into dm is equal to dm c square. dm c square. So now you have to observe equation number 1, the left hand side is equation number 2, the left hand side equal. That's why we have to equate the right hand side. Dt is equal to dm into c square. Now we need to calculate the kinetic energy. How we have to calculate the kinetic energy? You integrate integral 0 to t or 0 to k, you have to keep whatever it may be. So that is the kinetic energy you have to keep. Integral 0 to t, t means kinetic energy here. Integral 0 to t is equal to a c square into integral m0 to m, the rest mass to variable mass, into dm. C square is the constant. Now you have to apply the integrate first. Integral dx is equal to x, you will get the t, c square into, you have to take it as a m, you apply the upper limit and lower limit, then you will get which one you are getting. Once you have to see, you are getting the expression T is equal to kinetic energy is equal to c square into m minus m naught, m minus m naught. So therefore kinetic energy is equal to mc square minus mc square minus m naught c square is there. So now you have to take it as a, this is the kinetic energy of the particle, kinetic energy of the particle or body, kinetic energy of the particle. This one is the total energy or relativistic energy, total energy or relativistic energy. Which energy it is? Relativistic energy, total energy or relativistic energy of the particle. This one is the rest energy of the particle, or this energy we also call it as a proper energy, rest energy, or we also call it as a proper energy of the particle. From this what we have to write, mc square total energy is equal to kinetic energy plus m naught c square. So total energy, this total energy we have to take it as a energy E, E is equal to mc square. What is the total energy? We have to keep kinetic energy plus, so rest mass energy we call it as a total energy. Total energy we also call it as or relativistic energy. Which energy it is? Relativistic energy. So this relativistic energy, this formula we call it as a, so which formula it is? From this, energy is proportional to the m. Energy is proportional to the m means energy if it is more, so mass also more, energy will more, energy is more, mass also will more. So this is the relation. This relation we call it as a Einstein's mass energy, Einstein's mass energy equivalence equation, equivalence Einstein's mass energy equivalence equation. This is very important. Like this we have to derive the Einstein's mass energy equivalence equation. Once again you have to see how we get the Einstein's mass energy equivalence equation. First you have to take any body or any system of the particle. So that body is apply force on that body. Because of that force, this body is displaced from its initial space dx. So right, how much velocity it is moving? It is moving with velocity v. According to the Newton's law of motion, F is equal to dp by dt. Now you have to follow this procedure. Equation number 1 you are getting, that work done is nothing but, that work done is equal to the kinetic energy of the particle is equal to the work done by an external force increasing the speed of the particle from 0 to the some value of v. So therefore, but equation number 1 we got the kinetic energy of that particle, but we know mass in relativity based on this mass in relativity, we are getting one more expression, that is the equation number 2. From equation number 1 and 2, we are comparing the left hand sides of the equation number 1 and 2. Therefore, left hand side of the equation number 1 and 2 is equal. That's why right hand side you have to equate. You will get the kinetic energy is equal to m minus m naught into c square we are getting. From this kinetic energy, so what we have to write? Total energy of the expression we are writing. That total energy we are calling it is a relativistic energy. That relativistic energy is nothing but the sum of the energies of the kinetic energy and the rest energy or proper energy of that particle. Clear? Now once again you have to see what we have to see once here. This is the Einstein's universal equation between this E is equal to mc square. E is equal to mc square formula is, this formula we call it as a Einstein's universal equivalence equation between the mass energy, between the mass and energy. This is the Einstein's universal equivalence equation between the mass and energy. The total energy also call it as a relativistic energy. The total energy we also call it as a relativistic energy of the particle is the sum of the rest energy and the kinetic energy. The sum of the rest energy and kinetic energy. Suppose m naught c square we also call it as a total energy of the object measured in a frame of reference in which the object is at rest. When the object is at rest, that object energy we call it as a rest energy. This energy we also call it as a proper energy. Clear? This is very very important. So you able to try to understand what is E is equal to mc square. Clear? From this E is equal to mc square, so we have to explain different ways. The change of mass to other forms of the energy or vice versa. Mass, the change of mass, it will give the energy, or change of energy, it will give the mass. The change of energy, it will give the mass. So vice versa is there. Have been experimentally confirmed. How it will be confirmed experimentally once you have to see. In elementary particle physics, pair production and annihilation experiment is there. There we are using this mass is converted to the energy is converted to the mass. Not only that, electromagnetic radiation under certain condition can be converted into electron and positron. Electromagnetic radiation under certain conditions can be converted into electron and positron. So there also we are getting this one. That is also elementary particle reaction only. Not only that, this energy produced into nuclear power plants based on the nuclear fusion reaction can work. So the energy produced into nuclear power plants is a result of the loss in mass of the fuel during the fission reaction. So because of the mass variance, there is a energy created. That energy is the nuclear energy. Even a radiant energy, that is the solar energy, if you have to consider, we receive from the sun. That radiant energy is an example of conversion of mass into energy. This radiant energy how created? Because of the nuclear fusion reaction, this radiant energy can get. So many examples I will teach you after some time. Whenever it will come, all these things I will teach in the nuclear physics. All these phenomena will come once you have to remember. Now we will see for the relation between the total energy E. What is the total energy now? E. Momentum P. You have to take the momentum P. and the rest energy is equal to E naught, that is E naught is equal to m naught c square you have to keep. So, we want to derive the relation between these three things. How we have to derive the relation between the total energy, momentum and rest mass energy? How we have to derive? Once you have to see the mass in relativity equation, you have to take mass in relativity equation, you consider the mass in relativity equation, m is equal to m naught is divided by square root of 1 minus v square by c square. This is the relation between the mass and energy. Now you square on both sides. M square is equal to m naught square is divided by 1 minus v square by c square, 1 minus v square by c square, and you cross multiply m square into 1 minus v square by c square is equal to m naught square. 1 minus v square by c square is equal to m naught square. Therefore, you have to multiply with c to the power of 4 on both sides. What you have to do? Multiply above the equation c to the power of 4 on both sides. So, c to the power of 4 both sides you have to multiply. What will happen once you have to see? M square c to the power of 4 into c square minus v square is divided by c square, which is equal to m naught square c power 4. Now you have to see c square 1 c square get cancelled. M square c to the power of 4 minus m square, so c square v square minus m square c square v square is equal to m naught square c power 4. M naught square c power 4 we are getting. M square c power 4 is equal to, m square c power 4 is equal to, which one we have to write here? M square c square v square plus m naught square c power 4 plus m naught square c power 4 is there. So, therefore, what we have to write here? mc square whole square I am writing, which is equal mc square whole square I am writing, m into v whole square into c square I am writing, plus m naught square c power 4, m naught square c power 4. So, therefore, what we have to write? mc square is equal to, we know according to the Einstein's mass energy equivalent equation, E square is equal to m into v is equal to, we know that is the momentum, p square c square plus m naught square c power 4. This is the expression. So, which expression it is? This expression is energy, total energy, momentum and rest energy relation. So, this is the relation, required relation between whom? Required relation between energy, momentum and rest mass energy. This is very important. So many times your competitive people are asking this question. So, not only this, if you have to take so this relativistic energy equation relation, E square is equal to p square c square plus m naught square c power 4. This expression if you have to consider, if you have to take m naught, rest mass is equal to 0, m naught is equal to 0 if you have to consider. So, what will happen? What is the m naught? Rest mass of the particle. Rest mass of the particle is equal to 0. Rest mass of the particle. Rest mass of the particle is equal to 0. Therefore, if you have to take, so what you have to take once you have to see, E square is equal to p square c square you are getting. E square is equal to which one we are getting? P square c square you are getting. E square is equal to p square c square. Squares you get cancelled. E is equal to p into c. E is equal to what you are getting? P into c. But E is equal to which one we have to write here? mc square is equal to m into v into c. 1c get cancelled, 1m get cancelled. Therefore, v is equal to what we are getting? V is equal to c we are getting. Therefore, if it is mass is equal to 0, rest mass is equal to 0, hence the massless particle, rest mass is equal to 0 means that particle we call it as a massless particle. Massless particles are there, photons and neutrinos are massless particles are there, hence massless particles must travel at the speed of whom? Must travel at the speed of light. Therefore, what we have to write? Massless particles must travel at the speed of light. What are the examples of the massless particle? Photon is the example of the massless particle. Neutrino is the example of the massless particle. Gravitons is the example of the massless particle. Therefore, these massless particles must travel at the speed of whom? At the speed of light velocity. At the speed of light, this massless particle can travel. We have to tell this. So now we have to explain, already I told the examples of the mass energy equivalence principle. Examples of the mass energy equivalence principle are experimentally verification of E is equal to mc square, or experimentally verification of E is equal to mc square. The first one is annihilation phenomena. So what is the annihilation phenomena? What is the pair production phenomena? Once you have to see. First you have to take a one particle you have to consider. This is the particle you have to consider, particle. Another one you have to take it as a anti-particle, you have to take anti-particle. One is particle, another one is anti-particle. If particle means you have to take it as a electron, that anti-particle is the positron. Clear? So these particle and anti-particle gathering together, so what will happen? Once you have to see particle and anti-particle gathering together. So if it is gathered together, so they should form, some energy. They should form some energy. That energy we call it as a photon energy. Which energy it is? Photon energy. So this energy we call it as a photon energy can form, right? This energy can form. Once a particle and anti-particle gathering together, come together, they can, this process we call it as a annihilation process. Which process it is? It is a annihilation process. This process we call it as a annihilation process. In this annihilation process, which phenomena can occur here? Mass is converted to the energy. So here particle and anti-particle, the mass is converted to whom? The mass is converted to the energy. Such type of phenomena we call it as a annihilation phenomena. So this is very, very important. Whenever I teach the nuclear physics, in that time I will derive the expressions also. Annihilation and pair production expressions also have to derive. But now you learn the concept of that. One particle and anti-particle gathering together, then there is a photon is releasing. There is a photon is releasing means because of the mass of the electron and anti-particle positron, there is a energy is releasing. Such type of phenomena we call it as a annihilation phenomena. Clear? Annihilation phenomena. That only I wrote. When an electron, a positron come together, they can annihilate with the production of gamma rays. It is found that the energy associated with the gamma rays is equal to 2mc square. How much energy is released? That energy is equal to 2mc square energy is releasing. Clear? So that gamma ray energy is equal to 2mc square associated with the mass of the both particles. Associated with the mass of the both particles. Such type of phenomena we call it as a annihilation phenomenon. If the reverse of this, suppose if you have to take a gamma ray, if you have to take, this is what is this? This is the gamma ray or photon. This gamma ray we also call it as which one it is? this gamma ray we also call it as a photon. So this photon, if you have to give the energy is greater than or equal to 1.02 mega electron volt, if you have to give the energy, so what will happen, you have to see 1.02 greater than energy you have to give, one is going to the particle, in another one is going to the particle electron, another one is going to the particle positron. So these two pairs are coming, that's why this process we call it as a pair production process. In this pair production process, what will happen, here you have to see energy, gamma ray energy is converted into the particles. Particles means mass. So in the pair production, which phenomena is converted into which, energy is converted into mass, such type of system we call it as a pair production, where we are learning in the nuclear physics only we are learning. From the gamma ray, a pair of electron and positron is produced. This phenomena we call it as a pair production. When we want to give, so you have to give the greater than 2 m naught c square or mc square energy only if you have to give, then only this gamma ray can converted into the electron and positron. Such type of phenomena we call it as a pair production phenomena. Which phenomena? Pair production. This pair production we also call it as a creation. This one we call it as a creation and annihilation process. This process we call it as a creation process. Which process it is? Creation process. This is the first example of mass and energy equivalence example. Now so many examples I will give. Suppose if you have to take a nuclear fission, where we are using this nuclear fission in atomic bombs. In atomic bombs we are using this nuclear fission, atomic bombs and nuclear reactors, atomic bombs and nuclear reactors we are using this, which one? That mass is converted to the energy, because if you have to take uranium 234 or 235, this is going to convert the energy. So the mass is going to convert the energy, delta m is going to convert the binding energy. This is the risk of nuclear fission. So not only that, in every nuclear reaction there is a energy is liberating. So in every nuclear reaction, suppose if you have to take any, suppose you have to hydrogen plus hydrogen, you converted into the helium, so plus some energy is releasing, because this energy is the, so difference of the masses in this, we are getting such type of energy. That energy we call it as a binding energy. In every nuclear reaction we have to take. So not only that, already we discussed in the solar energy, which phenomena? That is a nuclear fusion phenomena. So in a nuclear fusion phenomena, so what will happen? Hydrogen can collide and can form the helium. There is a cycle is there, and carbon nitrogen cycle also is there. So because of these reactions, a solar energy is forming, because of the solar energy, because of the mass defect in the components or in the elements, there is a binding energy is generated. So that binding energy is the solar energy. So not only that, in any body if you have to take, there is a internal energy of the body. There is a internal energy of the body. In any form increases its mass. Internal energy of the body is increases based on the mass only. This is also very important. I am giving the example once you have to see. A compressed spring is heavier than in the uncompressed state. And compressed spring is heavier than the uncompressed state. A hot body loses the masses in becoming cold body. A hot body loses the masses becoming a cold body, right? In such cases, the changes of energy is small, hence the changes of the mass also extremely small and is not measurable. So, but even though if you have to observe the statistical mechanics microscopically, you able to identify internal energy of the body in any form increases its mass. Mass is depending upon the internal energy of the body also. This is also one more example. Not only that, in Sommerfield's fine structure of spectral lines, relativistic Sommerfeld experiment we have to discuss in the atomic molecular physics. When I told the atomic molecular physics, I will teach the atomic models. So many atomic models are there. So there we have to discuss about the Sommerfield's fine structure of spectral lines on the basis of whom the relativistic variation of masses only. The relativistic variation of masses we have to discuss the which one? Sommerfeld fine structure of the spectral lines. Not only that, in Compton effect, the elastic collision between the photon and electron, suppose if you have to take a rest electron, if you have to consider, now you take the photon, you have to incident, what will happen? One unchanged frequency, one same frequency you are getting. So such type of phenomena, this is the gamma ray or photon, if you have to take, there is a collision between electron and photon, elastic collision between the photon and electron. Such type of effect we call it as a Compton effect. This Compton effect also we are getting what we are getting? We are getting the energy only we are getting, right? So the Compton shift based on the shift, so based on the variations in the shift, so we are getting the energy, right? So like this, so many examples are there. That's why Einstein is succeeded to explain the energy mass equivalence equation. We have to explain multiple number of examples, but those examples can't come in our exam. So these examples you have to try to understand. So these examples are very very important. Why I am giving? So many times they are asking in theoretical mode of the questions in JL, DL like that exam. Compton effect is which type of collision, whether it may be elastic collision or inelastic collision, like that they are asking. Which collision it is? It is a elastic collision. It is a fundamental particle collision. That fundamental particle collision belongs to the elastic collision. Clear? So this is the class today I have to take. So today onwards daily I will take the classes 6 to 8 a.m. in the morning in classical mechanics. Don't worry, this month or next month within the 15-20 days I have to wind up the entire the classical mechanics. So please share and subscribe our YouTube channel. Not only subscription, you have to tell to your friends also, right, to take our app and practice it. Without practice we can't expect to get the success in our competitive examination. Thank you.